Hello YouTube, RJ. Well, after my video about my hex beam where I did the drone footage looking at my hex beam, part of the video showed my solar array, and I got quite a few emails questioning about my solar array. So I thought maybe I'd do a real quick video for you guys just talking about this solar array and kind of bring you up, give you a lot of facts about it and such in a very short little video that some of you may not be interested in. If not, just go ahead and click off this video right now. But those that would like to learn a little about this solar system, hang in here. We'll talk about it. Let me do a quick flyby and let you check it out. I'll come back and we'll walk around it up close and talk all about it. And then I'll give you a lot of specs and show you how it all works. So let's take a look. Okay, with that, let's walk around the panels and let me describe what you're looking at and talk a little about them. So let me get you spun around here and we'll go take a look. One of the first questions I got is how many panels? It looked awful big to one person. It's 60 panels. I built the system 13 years ago, and at that time 250 watt panels were big panels, and that was the common panel to go in at the time. So they're all 250 watt panels. 60 of them, as I said, for a total of about 15 kilowatts of power. Now, one of the other questions that I had was going to relate to, we'll walk down here, let you take a look down here, was somebody was concerned that one of my panels was broke. And I had to explain that no, I don't have broke panels. I have dirty panels. And as you get down here, you're going to see, they were seeing this, and it does look from a distance as if something's broke, but it's just dirt. You see, I'm lucky. In Florida, we get heavy downpours in the summer, so I rarely have to clean my panels like most people. But that also makes you kind of lazy too. So what you're looking at is just dirt, and I have a particular situation right here with this one panel where the dirt normally ends up built up at the very ends of the panel here. If you look here. What you have is the metal frame of the panel creates a lip. And so when water washes dirt down, it traps a little water there. And of course, the heavier particles of dirt, it's almost like mining gold, as my dad says, and it settles the dirt out. But up here, what I have is I got a little low spot in my panel right there. That panel has a little bit of a sag to it. And so it tends to like to collect there really bad. So it washes off very easily. It's not hard to wash at all. Squirt a little Dawn dishwashing soap. I've got a particular brush on a long telescopic aluminum, very light aluminum rod that I can run up and down and wash them. It's pretty straightforward. It just means I have to drag hose all the way out here and such, and so it takes time. But most of the dirt collects where it really doesn't matter. You look at it and you think, oh man, you're losing a lot of power. But if you look down here, most of where the dirt is along this seam here where you're not making power anyway. Now that's not true up on this one. But most of them, if you look closely, are. It's all built up in the areas where the contacts, where the conductors run, strips of conductor runs up and down and along the bottoms, tops. So it really doesn't hurt output that bad. So, you know, every couple years I get out here and wash them. Takes me about an hour, maybe an hour and 15 minutes to wash. It's not bad. People in other parts of the country don't get the heavy rain. They have to do it a lot more often. So anyway, that's about the panels. They're 250 watts, as I said. So let's walk down here. And what you can see along the bottom is a little stub sticking out down here. What you're looking at is those are what we call the rails. Each panel is supported and bolted to 2 rails. You can see going up the bolts here, clamps here. Each clamp in the middle holds both sets of panel adjacent to each other with a little spacer. It keeps them separated the exact same amount. And so you have this 5 rows, 12 columns. That's where I get my 60 from. So we'll go around here and I can show you the real inner workings of the panel system. I can show you the inner workings of the array, I should say. What you have is, along this end, there's cables from every row. Let me get up here where you can see what I want you to see. You've got each panel has a output on the panel here with 2 DC connectors. DC power coming out, running over here. They run over and through, they have some connectors. These are MC4 standard solar connectors. This is an inverter. This is an Enphase M235 microinverter. In my system, each panel has its own inverter. And each inverter has an output. This is its input from the solar panel that operates it. It's powered from the solar panel, it doesn't have any other power. So it powers up when it gets enough power to power up, starts inverting the 30, 40 volts DC to 240 AC, which comes out and connects into this cable here with these connectors. These connectors are spaced on this big cable every length to get another panel. Here's another one, same exact setup. Very easy, it just repeats 12 times running down this cable. So this main 240 power cable comes along, comes down, comes into a combination box here, and that takes it into our junction box. So you have this same setup 5 times. Here's the next set. Here goes each of the 5. So the bottom ones go in the bottom. Let me get you down here where you can see. The bottom ones come in the bottom connection box and up this up this conduit, sorry, which is got a little support here. And each row comes over, connects in, runs in to this box. So let me see if I can get her open for you here. Oh, I'm sorry about that. Hard to do one-handed. So what happens is your 240 feeds from every row comes into the panel, and you have a circuit breaker for each row. 240 circuit breaker, 15 amps. And what happens is this power combines. It does the opposite of your power box in the house. Instead of bringing a massive power up into it and then splitting in a bunch of circuits, it brings a number of circuits in, combines them into a main power running out the bottom. This here is a ground. This here is your main power going into the ground. And so from that, and you'll notice one little jewel, one little device here, that's a surge protector. That's a lightning protector is what that is. All of this is grounded. You can actually see a ground conductor. Get over here. You can see a ground conductor right here running up, running over, if I can get it in the camera, running all the way up here, all the way up to here, and is clamped right here. And every rail has that clamp. So this whole unit is grounded together on that lightning ground down to ground. So this is my electrical, this is my physical ground. So that's the two different things you got going on there. And really that's it. You can see that these rails, how they bolt in. They bolt into both of the main pipes. Now when you look at this and you see all this piping, these piers, the up and down pipe, the piers, you'll probably notice they're quite substantial. Let me show you the end of one of them here. They're pretty substantial, and you might think this looks like RJ overkilled it when he built his array and designed his array, but that's not true. What the real truth is, the issue is, I'm in Florida, so we see hurricanes, so we have high wind ratings. Your minimum must be 135 miles per hour in my county, in my part of the county. And unfortunately, the next size down piping for this arrangement only got me to 130. So I had to go to the next level up. And the next level up takes you to 170 mile per hour wind. So this thing is rated for 170 mile per hour wind structurally. Luckily, we have not seen that. But to give you an idea how stout this is, every one of these piers, and if you look, let me scan over here, you're going to see there's 6 piers on each longeron. Every main pipe is connected to the ground with 6 piers. Each of these piers are sunk in the ground. Well, the hole is 6.5 feet deep. There's concrete all the way up to just barely below the surface. There's 6 foot of concrete. The pipes go down to about a foot above the bottom. There's holes drilled in it and pieces of rebar pushed through it 90 degrees to each other so that the concrete has a good hold on the pipes. It could never come loose, work loose in the concrete and come up and out. So I don't expect this thing's going anywhere anytime soon. It's pretty well built like a tank, guys. It's been through quite a few hurricanes, a lot of wind. So let's see, what am I missing? What questions did I get asked that I was missing? Oh, one question was, why so large, RJ? Why do you have such a large solar array? You know, what do you do when you need that kind of power? I have a pretty large home in Florida. Everything in this house is electric. Unlike up north where you guys do a lot of gas, this, and then some electric there. Everything I own is electric. I have no gas other than my generator. It takes a lot of power to run a house this size, especially in August. And if you look over here, you're going to see a little Chevy Volt, my wife's little Chevy electric car. Well, I had another one, which was red. That was my car. So for years and years, we had 2 Chevy Volt EVs, and we charged both those cars and ran this home, ran my garage, including all my CNC equipment, such that my hobby stuff, all from that solar array. And it provided more power than we needed. So it's done us very, very well. How much is my power bill? Well, for many years, my power bill was $10.43. Well, your first thought is, RJ, you said you make more power than you need. Why would you have a power bill at all? Well, let's talk about it. It's simple. Because even though I'm making more power than I need, the power company wants money to maintain the infrastructure. They are my battery. There is no batteries in the system. That was another question I needed to answer for somebody. There is no batteries. This is what's called a grid-tied array. When I make lots of power during a sunny day, I'm pushing power back in the grid and running my neighbor's house. That's absolutely true. Your nearest house takes your power. So once I use what I need, I push back out into the grid through the transformer on the pole, energize the lines, and since the houses near me have less resistive losses getting to them from me than from the power company, they take my power and they run on it. So that runs my meter backwards. So at night when I need power, When I take that power back, it just pushes my meter back the other way. It's true I make more power, but they want some money to maintain that system. They're my battery, and I'm okay with that. So the taxes and things like that used to be $10.43. And then they proposed and passed a couple years ago a minimum use fee of $30. So your bill had to be at least $30. So my bill has been for many years $35.63. Now you might think, well, that sucks. You got a array that makes more power than you need, and you still have to pay a power bill. Yeah, that's true. But keep in mind, while I'm paying those taxes and such each month, I'm accruing credits. So during the summer peak months when I don't make enough power to quite make my power bill, those credits get pulled down. But at the end of the year, in January, they have to come even that out. So they cut me a check. They don't really cut me a check. They put a credit on my bill. Guess what? That credit covers my bill for the month. I really don't pay a power bill. I just have to pay taxes up front, and I get paid back for the extra energy I produce. The other thing is how much? That's another real big question I had. How much, RJ, did you spend building this thing? Now, let me clarify, make sure you understand. This was designed by me, built by me, my father, and my 3 boys. There was no companies involved other than power company, just signing the paperwork and such. And of course, code enforcement with the permits. So how much did this cost? Well, before I can tell you how much it cost, I think you need to know how much it would have cost. I was an early adopter 13 years ago. Think about it. And when I called a couple solar companies just to get an idea of what they would charge to do this, the quotes were running $50,000 to $65,000. It cost all up, including the rubber mulch we put underneath the array, the rental equipment. We rented a trencher to run the cable to the house. We rented a bobcat with a big auger to put those holes in the ground. We had to buy concrete from the concrete company, come in back in here with a cement mixer and dump concrete. All the piping, all the hardware. That hardware is a kit. All those brackets and such is a kit. You buy the pipes yourself, but that's a kit from a company called Iron Ridge. Solar panels, inverters, cable, everything. I had $18,100 when I completely in. People say, well, when did it break even? Well, it broke even from the moment I put it in because I lost my power bill. But the truth is, if you want to say, how long did it take you of savings in the power bill to pay that $18,100? It was about 4.5 years. So for almost working towards 10 years, this thing has literally been producing money for me each and every month. I figured it up a long time ago, and I was pushing something like $30,000 savings. So for those that ask the question, is the solar worth it? I don't know about now. I have no idea what your rules and everything is, but for me, it has been one of the greatest decisions me and my wife ever made. How does it work? Well, you saw the line going in the ground. That's 240 volts, just like what comes off of your transformer. In my case, it ran back across the yard, and we can walk over, and I'll cut the walk, but we'll walk over and I'll show you the panel where it brings in and explain exactly how it works. Okay, here we are. And what you're looking at here is the box here. This is my solar coming in up through here. And the way it used to work is it came in, it went to this photovoltaic disconnect switch here. It used to go into my house to a circuit breaker, a 60 amp circuit breaker in the house, and connect directly to my panel. Now, many years ago, we put the Generac whole house standby unit in, and it couldn't be hooked that way anymore because I could not have the generator and it connected together. That's a really bad thing. Good way to blow a bunch of stuff up. So when they put the Generac unit in, they changed and brought my power up through there with a circuit breaker in there into the main switch, the auto switch for the generator. So this is now tied directly to the power company side of the switch. So if I switch to generator, when it switches from power company power coming in at the bottom here, when it switches over to the generator, power company comes in here, power company comes up in here into the switch. When it switches from there, which my solar's connected to, when it switches over here to this line which runs to my generator, the solar gets disconnected from the electrical system. stays hooked onto the power company side. Now, that's not dangerous because the solar inverters, if they do not detect the power company's power, they instantly shut down. So they're always safe. So the other thing is I have to put in a dual reading meter. If you watch my meter here, let's see if we can get to where we can see good. You'll see level 3 it says. Second, it's going to give you 2 different readings. And here we go. And then you get a 1 and it gives you a reading, okay? Those 2 readings are how much power I've taken in. There's 2, had 1 and 2. 1's how much I took in for the power company. 2's how much I've sent to the power company. And they have nothing to do with each other. They're just from the day I powered it up, the going to the power company, the 2 of them just count their separate directions. It's a bi-directional meter. It measures going into my house. It turns around and measures power going out of my house to them. So what happens to that power? Like I said, runs over to a power pole right up here. Let's see if we can get her in. Run up to that transformer, energizes it, and my neighbors enjoy solar power from my home. So that's pretty much it. I don't know if I have much more to say. Hopefully that answered all the questions everybody was asking. If not, I'm sorry. Yes, I mowed and have not weed whacked yet, so I'm sure somebody will comment on that. But give me a few minutes. That's why my hair looks like it does. It's fixing to rain in a few minutes, and it's about 91 degrees and about 95% humidity. So if you don't live in Florida, you don't understand it. But this is what your hair looks like 5 minutes after you walk out of the house, no matter what, because you start sweating instantly because it's in the 90s and the humidity is mid 90s. So got a little cool breeze right at the moment because the storm's coming, but I need to get done with this video so I can go grab the weed whacker and do some weed whacking real quick. So, hey, thanks for hanging out in this video. I hope you learned something you wanted to know for those that were asking about it. So hopefully this helps you. And, you know, if you have any more questions, feel free to put it in the comments. Let me know. Those that like to email me, I really appreciate it if you put it in the comments. I want everybody else to see. I want to see the conversations between each other. So thanks a lot for hanging out with me today. And most of all, hope to see you in the next video, guys.